Here in this video, we are solving two questions that appeared in NEET 2023 in a physics chapter called Gravitation, first year. Let us see what is that question is. First question is, two bodies of masses m and 9m are placed at a distance r. Gravitational potential on the line joining of the bodies where the gravitational field is equal to 0. Let's understand what is given for you. It is given that there is a body of mass m. There is another body of mass 9m separated by a certain distance. In between, you have kept a new body of mass m3 and that experiences zero gravitational field, where gravitational field is equal to 0 means gravitational force on this mass equal to 0. Let it is kept at a distance x from m. It becomes automatically r minus x from the other distance. Now on this m3, this m applies a kind of force of attraction. This m, on this m applies a force of attraction. It pulls towards it. How much is that? We have a formula na, G m3 and this mass is m by location x square. On this same m3, this 9m also applies a attraction towards it. That's how much G m3 9m by r minus x whole square. G m3 is common, it will cancel. M also will cancel. So r minus x by x whole square equal to 9. That implies take a square root on both the sides. R minus x by x is 3. R minus x equal to 3x. R equal to 4x. X equal to r by 4. So what we have got is this, where the electric field is 0, gravitational field is 0 is at a location of r by 4 from this. This becomes automatically 3r by 4 because total value is r. Now on this point P, you need to find out the gravitational potential. Now our aim is actually to find gravitational potential. What is gravitational potential? We need to know. Gravitational potential is like electric potential, work done in bringing a unit mass from infinite distance up to a particular point. Work done is nothing but gravitational potential energy, that is minus gmm by r by m is there. This m will cancel. So gravitational potential is minus gm by r. A minus is a symbolic way of saying that the body is still attracted and attached to that of the earth. Now on this point P, I need to find gravitational potential, which is a scalar. Due to this m, there will be some gravitational potential. Due to this 9m, there will be some gravitational potential. Therefore, total potential at P is, due to this m, minus gm by r, that is x, that is r by 4, minus gm by this distance. Gm is how much? Actually 9m by 3r by 4. So what happens? This 4 will go to the numerator, minus 4 gm by r. This 4 also will go to 4 into 9, 36, minus 36 gm by 3r, 36, 3 12s then. So if you rearrange, minus 4 gm by r minus 12 gm by r. R is same, minus 16 gm by r. Option D is the answer for that problem. So this problem consists of two concepts. First, I need to find out where the gravitational field is 0. I have found it by equating the two forces acting on that this way. On that point, I need to find a gravitational potential. Gravitational field is a vector, whereas gravitational potential is a scalar. Be careful about it. That's one question. There is one more question given for you. See this. A satellite is orbiting just above the surface of the earth with a time period t. If d is the density of the earth, g is the universal gravitational constant. What is 3 pi by gd is? So the first thing that we need to understand is, when a satellite is revolving around the earth, say this is the earth of mass capital M, this is the satellite of mass M. When it is revolving in a circular motion or a rotatory motion, there must be a centripetal force. What is that centripetal force is? Mr omega square. I can write mv square by r also, but as I want time period, I have written mr omega square. Who is providing the centripetal force? The gravitational force between these two. G, capital M is the mass of the earth, small m is the mass of the satellite, by r square, where in both the cases r is the radius of the earth itself, because it is moving close to the surface of the earth. Then the small m's can be cancelled. Then omega square equal to gm by r cube. But if you observe carefully, he has given density, not the mass. So I have to convert that mass into density using a relation as density equal to mass by volume. Mass can be written like density into volume. Assuming earth approximately a sphere, volume is 4 by 3 pi r cube, where r is the radius of that. So in the place of this mass, I can substitute this value. Then what happens? That implies omega square equal to capital G by r cube. In the place of mass, density 4 by 3 pi r cube. So this r's will cancel. What is remaining is omega square equal to 4 by 3 gd pi. That's what remaining. But omega is 2 pi by t, d theta by dt. For one rotation, d theta is 2 pi. Time taken for that, omega formula. Rate of change of angular displacement. After one rotation, it covers an angle 2 pi. Time taken to complete one rotation is called t. So 2 pi by t whole square equal to 4 by 3 gd pi. That is 4 pi square by t square equal to 4 by 3 gd pi. 4 and 4 can be cancelled. 1 pi will cancel. So what is remaining? Pi by t square equal to gd by 3. So if I have to calculate, if you cross multiply this, gd and 3 square equal to 3 pi. So t square equal to 3 pi by gd, where d is density. He is asking in the question, this 3 pi by gd represents what? It's obvious that it is going to represent t square. That is the answer for the problem. That's how we solve these problems in gravitation that appeared in NEET 2023. Thank you for watching.